So in this video today, the 1.4 notes, we're going to go over coordinate proofs by proving by midpoint. So by the end of the lesson today, you're going to be able to determine the type of quadrilateral represented with coordinate points and justify it by using the midpoint formula, at least for part of your justification. Okay, so parallelogram. To prove a quadrilateral is a parallelogram, you have to show that its diagonals bisect each other using the midpoint formula. Here's your blanks, bisect in midpoint formula. With a rectangle, to prove a quadrilateral is a rectangle, you show that its diagonals bisect each other and are congruent using the midpoint and the distance formula. Or, remember, we sometimes don't use the distance formula, we do rise over run, so we use Pythagorean's theorem. Rhombus, to prove quadrilateral's rhombus, show that its diagonals bisect each other and are perpendicular using the midpoint and the slope formulas. And then with a square, to prove a quadrilateral is a square, we show that its diagonals bisect each other, are congruent, and are perpendicular using the midpoint, distance, and slope formulas, okay? So here's your blanks. Go ahead and fill them in. You can pause the video if you want to do that. So today we will classify a quadrilateral formed by midpoints. The midpoint formula is used to determine the coordinates of a midpoint. So you can use the midpoint formula. And I'm pretty sure this should have been underlined, y'all. Midpoint formula right there. That's what was underlined in your notes. So midpoint formula, if you have x1, y1, and x2, y2, there are 2 points on the coordinate plane, then the midpoint of the line segment that joins these 2 points is, so this is our x value of the midpoint, and this is our y value of the midpoint, okay? So then we would get an ordered pair, x, y, okay? So our first one says, what is the midpoint of segment AB? So if we want to find the x value, so I'm going to say xm, so we're going to take our x1, y1, x2, y2, right? So we're going to take our x values, and we got -1 plus 3, and we're going to divide that by 2. That's kind of our average, right? If we add 2 points together and you divide by 2, then you get the average. So, so that's 2 divided by 2, so that's 1. That's our x value. And then we're going to find our y value, okay? So our y value of the midpoint is going to be -1, sorry, not -1, 5. 5, and if you add a negative, you actually subtract, right? So I'm just going to do it like this. So that's going to be 5 minus 1, that's 4. 4 divided by 2 is 2. So our midpoint of AB is 1, 2. Okay? So the next one we're going to do together. So this one says, what is the midpoint of segment MN? So once again, we're going to label x1, y1, x2, y2, and I'm going to do the x value of the midpoint. So I'm going to get my x values here, okay? So this is going to be 2 plus 2 divided by 2. That's 4 divided by 2, which is 2. So the midpoint, obviously, between the same x values is that value. Going to do the same thing with our y value. Okay, so we're going to do -5. If you add a -3, you're subtracting 3, right? So if you combine two like terms, you just get a bigger like term, right? So that's going to be -8 divided by 2, which is -4. So our point here is 2, -4. That's the midpoint. All right, I want to see if you guys can do the next one yourself. So go ahead and pause the video, do this one, and come back to me when you're done. So here again, x1, y1, x2, y2. So our xm and our ym, midpoint of those, are what we're solving for, right? So we're going to do -5 plus 3 divided by 2. That's -2 divided by 2. That's -1. And then we're going to do -3. -3, and if I add a negative again, I'm subtracting, right? And remember, if it's the same point, you're going to get the same point, okay? And that's because, obviously, the midpoint between the same point is the same point. So -6 divided by 2 is -3. So here's our midpoint of this one. It's -1, -3. Okay. So for the next one, it says determine what type of parallelogram ABCD is using the diagonals. Okay, so to do this, we're going to make sure that it is a parallelogram. So we're going to do two things. We're going to find the midpoint of AC. So AC, so point A is 0, 10, and point C is negative 2, negative 1, okay? So there's my x1, y1, x2, y2, right? x1, y1, x2, y2, okay? So when I do this, I'm going to do 0 minus 2 divided by 2. That's negative 2 divided by 2, which is negative 1. And that's where it looks like it is, right? Right there's our midpoint. Y'all see it? Okay. So then we're going to find the y value. So that was our x value, y'all, xm. So now we're going to find our ym. So it's going to be 10 minus 1 divided by 2. That's 9 divided by 2, so that's 4.5. Okay, so this point is negative 1, 4.5. Now, what's important about that is if this is a parallelogram, and it says what type of parallelogram, the diagonals bisect each other. Okay, so they have to bisect each other for us to even determine if it's a parallelogram or not. So now we're going to look at, sorry, DB. And with the B, my points are, what is that, negative 6, 7. And then B out here is 4, 2. Okay, so once again, we're going to add our x's. x1, y1, x2, y2. So we're going to go for our x, our midpoint of our x, negative 6 plus 4 divided by 2. That's negative 2 divided by 2. That equals negative 1. Notice they're the same, okay, and they should be. If this is a parallelogram, okay? Then we got ym, and that is 7 plus 2 divided by 2. That's our 9 divided by 2 again, so that's 4.5 as well. So what does that tell us? That tells us that the diagonals bisect each other, so we know this is a parallelogram, okay? First of all, that's important, because it can't be anything else that we've talked about if it's not a parallelogram, okay? Because that's the property of a parallelogram. Now we're going to check the length of these. And we're going to do this our old school way. So we're going to count down and over. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to find the length of AC. So I'm going to do the square root of 11 squared plus 1, 2 plus 2 squared. So that would be 121 plus 4. So that's the square root of 125. Okay, so now we're going to do the same thing with DB, okay? So I'm going to do this in a different color. Let's choose green here, okay? So here again, if I'm looking for DB, so I'm going to go straight down. Whoops, not that far. And then straight over, right? So we're creating our right triangle again. So this time we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when we're looking for the length of DB, we're going to do 5 squared plus 10 squared, right? So that's 25 plus 100. And guess what? That's the same as what we got up there, square root of 125, right? So if AC and DB, which are our diagonals, if AC is equal to DB, then we know this is a rectangle, because its diagonals are congruent. Okay? All right, so I want you guys to go ahead and do the same thing here with number, you do 3, and then come back to me when you're done. Okay, I want to label these points while y'all are working. R, S, Q, R. So Q is negative 2, negative 1. R is negative 1, 2. S is 1, 2, 3, 4, 1. And T is 1, 2, 3, 3, negative 2. Okay, so we're going to talk about our diagonals again. Okay. Diagonals bisect each other. And if they do, then what do we know it is? A parallelogram, right? So it's asking us, is this a parallelogram or is this a rectangle? Okay. So here we go again. So I'm going to do QR. So I'm going to find XM and YM. So my X is negative 2 plus 4 divided by 2. That's 2 divided by 2 is equal to 1. And then we've got our y values, negative 1 plus 1 divided by 2. So that's 0 divided by 2, which is 0. Okay, so that would be 1 comma 0. And then we've got RT. That was not QR, y'all. That was QS. Wow. Oh, sorry, y'all. QS. Now we're going to do RT. Sorry. RT is equal to our x's again. So xm, ym. So we're looking for our midpoints again. So we're going to add our x's. Negative 1 plus 3 divided by 2. So that's 2 divided by 2 again. There's our 1. Then we got 2 minus 2. So divided by 2, sorry. So that's again 0 divided by 2. So that's 0. So this is 1, 0 again. So we know this is a parallelogram. Now let's again check the length, okay? So I'm going to go down here and over. So that's 1, 2, 3, 4. 4 tall, 1, 2, 3, 4 wide, okay? So the length of RT, since I started with that one, would be the square root of 4 squared plus 4 squared. So that's going to be 16 plus 16, which is equal to the square root of 32. Let's check the other one. Okay. So now I'm going to do it in green so it looks a little different. So here again, we're going to go down and over. So this is 2 tall and 1, 2, 3, 4, 5, 6 wide, okay? So this one is going to be for QS, square root of 2 squared plus 6 squared. So that's going to be equal to the square root of 4 plus 36, which is the square root of 40. So what do you notice here and here? Are those equal? No. So this is simply a parallelogram. Okay? If the diagonals are not congruent, it can't be a rectangle or a square, because remember, a square is a rectangle, okay? So keep that in mind as you're working through these types of problems.